Assalamualaikum warahmatullahi wabarakatuh, and hi to our respectable lecturer, Professor Madya Technologist, Dr. Muhammad Zahir bin Hassan. So today we would like to present about conduction graphical analysis on heat transfer. So this is our team member, which is first Muhammad AIDIL FADZLY bin SAIDINAR OMAR, AMIR NAZRIN bin HUSIN, next Muhammad ZUHAIRI FIKRI bin JAMALUDIN, ASYRAF Daniel bin AHMAD Ma'ruf, and last Muhammad ASYRAF bin Muhammad YUSOFF. For introduction, a fin plate, also known as a fin plate or fin heatsink, is a device used to enhance heat transfer in various applications. Fins increase the surface area of the base plate, allowing for improved heat dissipation. Fin thickness affect both structural integrity and heat conduction efficiency, with thinner fins allowing for better heat transfer but promising mechanical strength. Fins are typically made of materials with high thermal conductivity, such as aluminum or copper, to facilitate efficient heat transfer. Fins enable heat transfer through conduction, convection, and radiation, with the dominant mode depending on the operation condition and design parameters. Objective: the first to create two different fin surface according to our creativity using SolidWorks software, and the second to perform heat transfer simulation process using SolidWorks software.
So now I will brief about the problem statement. Firstly is the miniaturization and increased power density of electronic components pose challenges to efficient heat dissipation. Second, elevated temperatures can adversely affect the performance and reliability of electronic systems. Lastly, inefficient heat dissipation mechanisms can result in increased energy consumption as cooling systems need to work harder to maintain desired operating temperatures. So now I will talk about the specification needed. Firstly is the ambient temperature is set up to 301.15 to 307.15. Second is convection coefficient is 5.03. And number third is average temperature on cold sides in Celsius, which is 76.6. And then fish base size, which is 40 mm times with 40 mm. And number 5 is average heat flux on cold sides, which is 105,000. And then average temperature on cold side, which is Celsius, 97.3. Okay, about the material, aluminum alloy, 1060. Okay, so we can talk about the property used. So such as elastic modulus, Poisson ratio, shear modulus, mass density, tensile strength, compressive strength, yield strength, thermal expansion coefficient, thermal conductivity, specific heat, and material damping ratio. The all property have the value and the units given.
Okay, next, if we look at the isometric view, we can see the width is 40 mm, length is 40 mm, and the height is 44 mm. At the front view, the height is 44 mm and the width is 40 mm. At the top view, we can see that the fin that we have is 40. Each diameter of the fin is 2 mm. So, the highest temperature is 331 Kelvin, while low temperature is 330 Kelvin. Heat flux, the highest heat flux is 6.91 exponent plus 3, and the lowest heat flux is 190. If we can, then we see that the graph temperature versus distance plot. We can see that at y-axis is temperature and x-axis is parametric distance.
Okay, the next heatsink is a side fin heatsink. There's an isometric view, right view, front view, and the top view. The width for the base and the length for the base is 40mm each, and the height of the heatsink is 95.52mm. The diameter for each pin is 2mm, and the amount of fin in this heatsink is 34 fins. Next, the highest temperature that we get from the hot side is 313 Kelvin, and the lowest temperature on the cold side is 312 Kelvin. For the heat flux, the highest heat flux that we get is 1.09 exponent plus 4 watt meter per square, and the lowest heat flux is 9.86 watt meter per square. And then that's a temperature versus distance plot that you can see is a perpendicular with each other.
Okay, for the discussion, number one is material. Both design use the same material, aluminium alloy 1060, which commonly used for manufacturer. So for the surface area, the design with more surface allows heat to dissipate through fins more efficient. Design, fin geometry, choose fin shape based on available space. Fin spacing, optimize spacing for airflow and surface area trade-off. Fin thickness, balance thickness for heat conduction and convective heat transfer. And the last one is conclusion. In conclusion, fin plates enhance heat transmission by increasing the surface area of the base plate. This improves heat dissipation by conduction, convection, and radiation. The form, size, and material of fins, as well as their design and properties, are critical for maximizing heat transmission efficiency. Fins in electronic system assist overcome issues such as insufficient heat dissipation, compact designs, and hotspot, resulting in better performance, reliability, and component longevity, continuous improvement in fin plate technology, and novel heat dissipation techniques provide potential options for effective thermal management in contemporary design. Okay, these our group members. The first one is, my name is Muhammad Asyraf bin Muhammad Yusoff.
My name is Ashraf bin Ahmad.
Next, my name is AMIR bin HUSIN.
And my name is Muhammad AIDIL FADZLY bin SAIDINAR OMAR.
And my name is Muhammad ZUHAIRI FIKRI bin JAMALUDIN.
Okay, sir, thank you.
Thank you, sir.
Kamsahamnida.
Kamsahamnida, sir.
Annyeong.
Annyeonghaseyo.
Annyeonghaseyo.
Okay, nice.